dielectric atom. Let's take a dielectric atom, and because of this dielectric atom, it's just we are taking a small size. Okay. You cannot say where it is positive, where it is negative. So that's why we are assuming a spherical cavity or spherical, just as sphere, spherical cavity or spherical sphere, you can say, just like this. Our atom also spherical shape, right? So dielectric means here positive charge and some of this side positive and another side negative charges will induce. Okay, this is the dielectric means. Okay, and outside of the surface also there is a charge will induce. Okay, because of this yes, charges will be available on the surface also. Okay, this is the dielectric atom, but we cannot say where is the positive, where is the negative. That's why we are assuming a spherical cavity. Okay, let's keep this material in a parallel plate capacitor. Okay, parallel plate capacitor means suppose if you apply some field also here, some voltage also, some side parallel plate capacitor means it is a two plates will be there. There one plate is positive charged and another plate is negatively charged. Okay, this is what parallel plate capacitor means. Okay, so because of this positive and negative charge, there will be another charges also induced. Another charges also induced here. This is plane surface of the atom. What I am drawing now. This is the plane surface of dielectric atom. So here plus charge is there, so it will attract negative charges of the. Suppose on the surface of the atom also we will have some charges, right? Some charges will be there. This will attract towards the negative charges will attract towards the positive terminal, and positive charges will attract towards the negative terminal. Okay. Now, so what is the local field? What is the Lorentz field means? Suppose we kept the dielectric material inside the parallel plate capacitor or in the field of external field. Okay. So here there is a, because of this parallel plate capacitor, because of this charge induction, there are many electric field act on this atom. Okay, many electric fields, different type of electric fields will act on this atom. The total field we are calling Lorentz field or local field or internal field. Okay, that we are saying total local field. You can write EL or something, whatever you can write. So here E1, E2, four fields are there. I will explain now. E3 and E4. Okay, E1 because this parallel plate capacitor always electric field direction is plus to minus, right? This is E1. So E1 due to charge induced on the capacitor plates. Okay, electric field due to capacitor plates. Actually, electric field mainly due to charge. So here already positive negative charge is there. That is E1. Second one, E2. E2 is due to charge, induced charge on the plane surface of the atom. Plane surface of the atom. This is E2. What is the E2 means? E2 mainly how E2 will produce means because of charge induced on the plane surface of the dielectric atom, that is E2. So here E3 inside the atom. Inside the atom also charges are induced. Okay, this is E3. And E4 means some of the charges will induce outside surface of the sphere or atom, you can say. Okay, this is E4. So here four type of fields are acting on a dielectric atom or dielectric material. These total field we are calling local field or total field. Now our job is to estimate total field. This all what are the E1, E2, E3. So first you will estimate E1. Okay, we will estimate the E1. We know from the dielectric material displacement vector is equal to epsilon and E. Epsilon and E. Okay, epsilon and E. So, and also we have one more formula also in the dielectric. Okay, in the dielectric we have one more formula also, that is here you can take the epsilon naught, free space permittivity. So we know one more formula, D is equal to epsilon naught E plus P. This is polarization vector, and D is this E epsilon naught is the permittivity of the medium. E is the electric field. Okay. Here if you take this one, this is equal to D. If you consider this, if you take a electric field E1, Here it is E1 and these two equal. Okay, this D and this D is equal. Okay. From there, epsilon naught E1 is equal. Epsilon naught E1 is equal. You can equal this one. Okay, epsilon naught E plus P. Okay. From there, you simply rewrite this expression. E1 is equal. You send this epsilon naught right hand side. Then you will get E plus P by 3 P by epsilon naught. Okay, this is equation 1. Okay, we have estimated the electric field due to capacitor plates. Okay, we know this is the actual formula, but we know D is equal to epsilon naught E plus P. We know this one. Just you substitute in place of D or equal these two expressions, then you will get the E1. Okay, now second one, next E2. E2 due to charges induced on the plane surface of the atom. Okay, that is generally capacitor electric field is given by E is equal to sigma by epsilon naught. This is the general electric field for a plane capacitor. Okay, so here you can replace this sigma with polarization vector. Okay, this is general equation. This is in case of dielectrics. Okay, now E2 is given by polarization vector for and this epsilon naught. Okay, so now what is the direction of E2? Direction, please tell me what is the direction? It is opposite to the E1, right? Opposite to the E1, or it is reverse direction, or you can take a minus, right? Is it okay? V by epsilon naught. Okay, now E3, next one is E3. So E3 electric field we have to estimate. So here you see that here, suppose inside, suppose here if you take any atom, here one plus charge is there, means here another negative charge will be there. Okay. Here two plus charges there, means here two negative charges will be there. Equally induced inside the sphere, equally induced inside the cavity or sphere. Okay. So because of this one, the electric field is equal and opposite within the atom. So total net field within the atom will be 0. Total net field within the atom will be 0. Okay, now these three we have estimated, E1, E2 and E3 we have estimated. Now our job is to estimate, main important is E4. Okay, that is little bit difficult, but it is easy. Okay. So up to now, is it clear to you guys? Any doubts here?
Yes,
Up
sir.
to now, any doubt you can ask. Otherwise, we will estimate E4 value. Okay. So it is very simple. We know first for calculating E1, we know D is equal to epsilon E1. Okay. And we know D is equal, displacement vector is equal to epsilon naught E plus P. So simply equal these two expressions, then you will find out E1. Okay. And E2 generally plane capacitor electric field is given by sigma by epsilon r. Just you replace sigma with polarization. In case of dielectrics, this is the electric field formula. Just it is equal to P by epsilon r minus sign. Why? Because we are writing it is a reverse. Okay, all E1, E3, E4 are left to right. Only E2 is right to left. That's why we are taking minus. Okay, and E3 in a atom equally charges are induced. Suppose 10 plus charge means 10 negative charges, minus charges. So total net field will be equal and opposite, that means 0. Okay. Now we will estimate the E4 value. Okay. Now estimate the E4 value. So now our job is to estimate E4. How we will estimate? So just I will give you some example here. So here I have taken a cricket ball, just like a, we have to estimate the, I can write here. I can write. So here some charge is there on the sphere. Okay, some charge is there. We don't know how much charge is induced on this one. So because of this charge, okay, because of the charge, there is a electric field also. There is a electric field also. We have to estimate this electric field. This electric field. So how you will estimate here? suppose you want to estimate directly, it's little bit difficult. So first, if we take any, what is the formula? Just first one formula for, suppose if we have a sphere or anything just like this one, okay, it is a radius having radius r and charge q. The electric field is given by q by 4 pi epsilon naught r square. Okay, epsilon naught r square. This is the formula for a induced charge on the sphere q and radius of the sphere is r. Okay, this is the formula, but here we don't know how much charge is induced. Okay, first we have to estimate this charge. After that, we substitute here, we estimate this electric field. Okay, for that, what we are taking, first we are, any doubt? Otherwise, please mute. If you have doubt, you can ask. So we are going to estimate that charge. Okay, first one. So we don't know directly, if you can estimate directly and substitute, but we don't know. First one, what we will do for estimating E, first we are taking integration of dE. Suppose dE means what? Here you have to write dq and 4 pi epsilon naught r square integration. Okay, this we have to do. First we have to estimate dq. After that, you have to integrate it. dq is equal to, you can write here, you can also write here dq by derivating or nothing but derivating q by epsilon naught r square. So this is can we write like this? Can we write? Suppose
Yes,
this
sir.
this derivation integration will cancel out, we'll get the same formula, right? We'll get this formula. Okay, if this integration derivation will cancel out, we'll get this formula. So we can write this way. Okay, now our job is to estimate dq. We have to estimate this dq on the sphere. We have to estimate dq on the sphere. Okay, the main beauty of this integration is, suppose you have a this rectangular or any shape, you have a suppose you want to estimate the area, total area, but it is suppose very lengthy area, we don't know, it is very difficult to find out. So equally make it some partition, equally make partition, and you take the small area element here, small area element here. Suppose total area you want a, okay, you want a. Instead of finding total, you have to count this one, 1 2 3 4, these all boxes. Instead of counting this all all boxes, first you take small area and you integrate that small area, you will get the total area of this rectangle or any shape. So here, if you want to count here, you can add 1 2 3 4 5 6, like that. You have to count all and you have to sum. That is gives you total area. But that is difficult, so that's why you take small area and integrate that small area. You will get the full area. So here also we have like this sphere. We are taking a small area element here. Okay, we are taking a small area element and we are estimating the area of this this one, area of this one, and from there we know generally formula is sigma is equal, this is surface charge density. What is this? What is this? Surface charge density. Okay, you can write surface charge density q by a, q by a. Suppose if you have a row, that is volume charge density q by v. Okay, but we don't want this one, this one we want. Okay, so from there, here q is equal to sigma into a, sigma into a. Okay, so from there, you have to first estimate, you want to calculate q, first you have to estimate area element. Okay, area element. So you integrate this one, or you can rewrite this one, q is equal sigma. In place of sigma, in dielectrics we have to write polarization vector. Okay, q is equal p into a. From there you remove this dot product, p into cos theta and a. Here a is there. So here you derivate this dq q and you will get the p cos theta and dA. So this is the formula. Q, if you want to estimate dq, you have to estimate dA. Area element you have to estimate. Okay, we are taking small area on the sphere, on the spherical cavity, whatever you can do. So you have to estimate Why we are taking small area instead of measuring total? We are taking small area and we are integrating that one. Okay. For that purpose only, what we have done yesterday and today also we are going to do same thing. So here this is the origin. Suppose this is the origin and this is the origin. You can take okay like this. Okay, this is the uh, you can take okay, like this. Okay, this is that, this is theta and this is d theta, this is d theta. Okay, here p and q, this is r. Okay, this is r. Okay, just like this. Okay, or you can if you write small area you can get the straight line. Okay, straight line like this. Okay, or you can write here also, or you can take this way also. Okay, just a minute please. Oops. Okay, anyway, no problem. Here you can take, this is the small area. Okay, we are going to find out dA. No, screen again. I will draw. Shall I draw this one? So here we are considering a sphere. Okay, sphere, and this is origin, and here we have a taking x-axis and y-axis. Here we are taking a small area element. Just before I have told you. Okay, this is some point we are drawing one line. Okay, and this is the it is making this place. This is theta and this is d theta. Okay, d theta. This is p and q, this is R. Okay, P and Q R. Okay, you can take this one. This one, P at point P. Okay, this is DT, right? So now we have to estimate this total area, means here this total area we want. So first you measure this one and the width. Okay, this one, the length and width you have to estimate. Okay, length and width you have to estimate. Okay, for that you have to estimate this angle and you have to estimate this angle. Okay, for that what we are doing, dA is equal 2 pi. This is total area. Okay, total we are covering 360 throughout the sphere, and PQ and QR, PQ and QR, this will give the total area element, or you can say area element. First you apply this q, here you can take AQR, triangle AQR, just apply sine theta. What is the value here? Sine theta. You just apply sine theta. That means what is the value? QR by AQ, right? Now we want QR. AQ, what is the value of AQ? What is the value in this triangle? What is the AQ? We have a sphere like this. Okay, here it is the radius R and this is Q, and you are taking a like this is P R. Okay, what is the A, what is the AQ value here?
R.
Yeah, R. That is also very difficult to follow. R. Okay, now QR is given by R sine theta. R sine theta. Okay, next one PQ you apply, and triangle APQ. Okay, you apply d theta is equal, same thing again, PQ by, here the this radius is R. Okay, from there PQ is given by R d theta. Just we are applying, say uh, triangle, we are applying sine theta and d theta. From there we are estimating these angles, these sides we are estimating. Okay, QR side and PQ side we are estimating. Then you substitute these two in dA. Now dA is equal, you can write 2 pi. Here what is the PQ? R d theta, and QR is equal to R sine theta. QR is equal to R sine theta. From there you can write 2 pi R square sine theta d theta, right? Is it okay? Area element. Any doubt? Is it clear to you, area element?
Yes, sir.
Just only this is the formula. Here dA is equal to 2 pi into PQ and QR. You are applying sin theta and d theta. Here we are taking two triangles. From there we are estimating the sides, this side PQ and QR. Okay, sides of the triangle. Okay, or if you know cylindrical coordinates are theta pi, sorry, spherical coordinates, you can estimate the area element directly. dA is equal to same thing you will get here. Okay, you can also estimate using cylindric spherical coordinates. Spherical coordinates you can estimate. Okay, so here what is the, see, this one is area element. Suppose if you take along these two angles, pi will vary 0 to 2 pi, 0 to 2 pi, and theta will vary 0 to 1, 0 to pi, and this r is 0 to r. Okay, here also you can estimate the same thing and you will get the same answer, but that is little bit difficult. You follow this one, it is easier. Okay, now thing is only we are estimating area element. After that, what is the dq now? dq is equal, what is the dq? Here we have written, right, dq p cos theta dA. Here p cos theta, actually p cos theta dA. Now what we got area element, we substitute here. Okay, dq is equal p cos theta and dA is equal to 2 pi r square sin theta and d theta. Okay, now from there again you rewrite this equation, uh, 2 pi, or we can write 2p, 2 pi r square e, r square p sin theta cos theta d theta. Okay, now dq we have estimated and substitute in the electric field, and you have to estimate total E is equal integration dE, right, dE. But here thing is, here we have a sphere, here we have a sphere, electric field only along the x direction. No, there is a, you can write electric field component, total electric field along the x component, along the y component. Okay, along the x and y component. So here total electric field is, you should write resultant electric field, you can write x component plus y component. So here what is the y component electric field? What is the value here, y component? What is the electric field along the y-axis? In your figure, just before we have discussed this one. So what is the, in this diagram, what is the electric field along the y direction? Please tell me. Here if you divide this on electric field along the x-axis and y-axis, what is the Ey and what is the Ex? So what is the Ey? Please tell me. What is the electric field along the y direction?
0.
Yeah, very good. Who is that? What's name?
Indu, sir.
Yeah, okay, thank you. So this is along the y-axis, electric field is 0. There is no electric field along the y direction. Only x direction only we have electric field. Okay. So the total electric field is given by only x component only. That's why here the electric field, this component is become 0. Then only we have x component of electric field only. So here, that's why if you divide this one, Ex cos theta and Ey sin theta, this is component, x component of electric field and y component of electric field. So this is becoming 0. Only we have Ex cos theta. Okay, Dex cos theta only we have. Okay, so here one more extra cos theta term is coming, because when you divide the electric field, y component is 0. Only we are having x component. Okay, from there Here total electric field is equal to DE means you have to DE means again here this cos theta term is coming. DE means here you can write the here dq by this dq cos theta by 4 pi epsilon naught r square. These things are there. So here you substitute dq value. Okay, generally what is the electric field? Q by 4 pi epsilon naught r square, right? So here if you derivative this one, here you have to derivate this charge also. Okay. So from there you are getting just you can write like this. E is equal integration of here dq means how much we got this much, right? This much. Okay. Here 2 pi p into 2 pi r square sine theta cos theta and cos theta, and here one more cos theta is there, so you write cos theta and d theta. Okay, the denominator we have 4 pi epsilon naught r square. Okay, now you will cancel out this r square, and here also r square, and 2 pi here 2 pi, and here you will get the 2. Okay, what is common here? P by 2 epsilon naught comes out, and integration here sine theta and cos square theta d theta, right? So now what are the limits? Theta limits 0 to pi. 0 to pi. Okay, now you integrate this one, you will get the E4 value. You will get the E4 value. So if you know formula, you can write directly. If you don't know formula, you can what is the answer this one? Can you solve this one? Can you tell me your answer? Anybody? Anybody solve this answer and tell me? Can you tell me? No? Otherwise, if you don't know formula, you take as cos theta is equal to x. Okay, then or you can take x is equal to cos theta, whatever you can take, it's not there. So you derivative this one, you dx is equal, what is the answer? Sin theta d theta, right?
DT.
So from there you substitute this one. Okay, you substitute these values here. So here you are substituting p by 2 epsilon, it is common, and integration sin theta d theta is there. That means what you can write? You can write dx. In place of sin theta d theta, you write dx. Okay, cos theta is equal to what we have taken? X. So that means here x square dx. X square dx. Now we have changed this value. We have to change limits also, right? Now if you change limits, x is equal to cos theta we have taken. So lower limit substitute theta is equal, first we will substitute theta is equal to 0. Okay, first lower limits. What is the value? Cos 0?
1.
1.
1. And second upper limit also we will substitute. What is the cos pi? Cos pi. What is this value?
0.
0. Math చేస్తున్నారు కదా, -1. Is it right? Wrong?
Yes, sir.
Huh?
Yes.
0 -1.
-1.
Okay. So now here values are +1 and -1. Okay. Now p by 2 epsilon naught. This integration is x cube by 3, right? X cube by 3, and here +1 to -1. +1 to -1. So you can rewrite this expression. Here p by 2 epsilon naught, and what you will get? What is the answer?
-2 by
-2 by 3. -2 by 3. Okay, -2 by 3 you are getting, right? So here these two will cancel. P by 3 epsilon naught. Here minus cos theta is equal to, here what is the derivation? Cos theta derivation. Cos theta derivation. What is the cos theta derivation?
Minus sign.
That's why you are not saying that one. Okay, here you have a minus. So here minus of minus plus. What you will get finally? P by 3 epsilon naught. Is it okay now? Now
Yes.
E4 is equal given by P by 3 epsilon naught. Now total electric field we will estimate, or local field or total field. E1 is equal to what is the value? E plus P by 3 P by epsilon naught, and E2 is P by epsilon naught, and E3 is 0, and E4 P by 3 epsilon naught. So now this second term and this third term will cancel out. From this equation, you can write total field or Lorentz field. You can write what is the answer? E plus P by 3 epsilon naught. This is the total field or local field or Lorentz field. So this much electric field act on the dielectric atom when you placed in a parallel plate capacitor, or when you placed in a external capacitor or external electric field. Okay, this is you have to derive. This is you have to derive. So this is the final answer, and this portion you have to, all things you have to do. First, what we'll do? First step is you have a sphere. Is it understand? Have you got the